Hello viewers, in today's class we are going to discuss one important definite integral, right? And here we'll solve this integral by method of substitution, right? So let us start. Now see, here we'll take this integral as I, right? Now here we have the integral from 0 to 2 and square root of x divided by 2 minus x, right? And we'll solve it by method of substitution. So the most appropriate substitution would be here, that is the trigonometric substitution, right? So here we'll take x is equal to 2 sine square theta, right? So here I will make this substitution, that is x is equal to 2 sine square theta. So if we differentiate both sides with respect to theta, then we'll get dx over d theta is equal to 2, and the derivative of sine square theta is 2 sine theta cos theta, right? So now dx can be written as 4 sine theta cos theta and d theta, right? So here we have this expression. Now uh, we'll change the limits accordingly, because we are changing the variable from x to theta. So here x varies from 0 to 2, right? So when x is 0, then here we'll take x is equal to 0 to get the value of theta, right? So we'll have 0 is equal to 2 sine square theta. So this implies that sine square theta is equal to 0, that is sine theta is 0, so theta is equal to 0, right? And similarly, when x is 2, then we can write 2 is equal to 2 sine square theta, and 2 and 2 get cancelled, so we are left with sine square theta is equal to 1. So sine theta is 1, so theta is equal to pi by 2, right? Okay, so now we can rewrite this integral in terms of theta, right? So now the limits are from 0 to pi by 2, and we have square root of x. X is 2 sine square theta, and in the denominator we have 2 minus 2 sine square theta, and for dx we can write 4 sine theta cos theta and d theta, right? So now let us simplify this integrand, right? So we can now write 0 to pi by 2, and here we have 2 sine square theta, and in the denominator c, if we take 2 common, then we have 2 times 1 minus sine square theta, and 1 minus sine square theta is cos square theta, right? So here we have 2 cos square theta, and this is 4 sine theta cos theta d theta, right? So now we can write it as 0 to pi by 2, and here this 2 and 2 get cancelled, and if we remove the square root sign, we have sine theta over cos theta, and here we have 4 sine theta cos theta and d theta, right? So now here cos theta and cos theta get cancelled, and we have 0 to pi by 2 and 4 sine square theta d theta, right? So now we have this integral, right? So now we can write this integral as 2 times 0 to pi by 2, and here we can write 2 sine square theta d theta, right? So we have written this 4 as the product of 2 and 2, right? So here we'll make use of one important trigonometric identity. So now we have cos of 2 theta is equal to 1 minus 2 sine square theta, right? So this is the important trigonometric identity. So if we take 2 sine square theta to the left hand side, we'll get 2 sine square theta is 1 minus cos of 2 theta, right? So now here we can write 2 times 0 to pi by 2, and 2 sine square theta is 1 minus cos of 2 theta and d theta, right? So now we have a simple integral. So we have I, here we have 2. Now the integral of 1 d theta is simply theta, and the integral of cosine 2 theta is sine 2 theta divided by 2, right? And limits are from 0 to pi by 2. So now we can simply substitute the limits and we'll take the difference. So we have here pi by 2. First we'll take pi by 2 minus sine 2 times pi by 2. So 2 and 2 get cancelled. So we are left with sine pi over 2. And when we take theta is equal to 0, we have 0, and here we have sine 0 over 2. And now this expression becomes pi by 2, and sine pi is 0, so this is 0, and here we have 0 minus sine 0 is 0. So now we have 2 times pi by 2, so 2 and 2 get cancelled, so we are left with pi, right? So the value of this integral is equal to pi, right?